This is question number 22, kinematics. Check your understanding, book Pathfinder. I'm reading the question first. When a deer was 48 meters from a leopard, the leopard starts chasing the deer and the deer immediately starts running away from the leopard with constant velocity. A leopard cannot run at high speeds for a long time and has to slow down due to fatigue. If we assume that the leopard starts with an initial speed of 30 meters per second and reduces its speed in equal steps of 5 meters per second after every 2 seconds interval, at what minimum speed must the deer run to escape from the leopard? So question is this: there is a deer, there is a leopard. Deer is 48 meters ahead of leopard. Deer is going with some constant velocity, suppose it's v. Leopard starts with 30. After 2 seconds, its velocity becomes 25. Then after 2 seconds, its velocity becomes 20. So every 2 seconds, its velocity is decreasing by 5. And we have to find the minimum v so that deer escapes from leopard. So this is the question. Now see, I've drawn a graph of leopard. This is xt graph. On this vertical axis, we have denoted x coordinate and the horizontal axis denotes time coordinate. And the leopard starts with a velocity 30. So the initial graph has a slope of 30. And therefore, in 2 seconds, its rise will be 30 into 2, that is 60. So leopard will reach to x equal to 60. Suppose its starting point is x equal to 0. So after 2 seconds, the leopard will be at x equal to 60. Initially, the slope was 30, then it's 25. So in next 2 seconds, the rise will be 50. So from 60 to an increase of 50, so it will reach to x equal to 110. Then its velocity becomes 20. The slope becomes 20. So for a time interval of 2 seconds, the slope will take the leopard to an increase in x that is equal to 20 into 2, that is 40. So from 110 plus 40, so that becomes 150 and so on. So this is how leopard is moving. This is xt graph of the leopard. Now this is suppose x equal to 48. So this is the initial point of deer. Now deer moves with a velocity, constant velocity. So the slope of deer is a constant slope, whatever be the slope. Now this cannot be the slope of deer because if this was the slope of deer, see what happens. At this point, deer and leopard meet, and after this point, the x of deer is less than the x of leopard. It means leopard is going ahead now. So it will easily catch the deer. If it is ahead of deer, leopard will slow down and catch the deer. So therefore, the slope of the graph of deer should be such that it just merely touches the graph of leopard. See, this is okay. This graph is okay because everywhere x coordinate of deer is more than x coordinate of leopard. It physically means deer is ahead of leopard. But since the question asks for the minimum velocity, see if the slope can be further reduced. And we have to make sure that x at every time x of deer is more than the x of leopard, so this graph is okay. But since the question asks for the minimum slope, for the minimum velocity, let's see if the velocity can be decreased further. Will this slope be okay? Yeah, this is also okay, because if this was the line of deer, even then x of deer is more than x of leopard at all instants. So this graph is also okay. So reduce it further. I'm reducing the slope further. So will this be okay? Yeah, this is just okay because at one point deer and leopard, they are coming at same x. But after that, x of deer is more than that of leopard. So this is just one point where they will be at same x. So any slope which is more than the slope shown at this instant will be okay. So since we have to find the minimum slope, we'll find the slope of this line. So for that, we'll draw a triangle. So this difference is 150 minus 48, that is 102. Well, this time difference is 6. So the slope, that is the velocity of deer, should be, velocity is nothing but slope. So that is 102 by 6. So that's coming out equal to 17 meter per second. So if deer runs with any velocity more than 17, the leopard cannot catch the deer. Okay.